Hello class, I wanted to provide you guys with a supplementary lecture as we step into the labs for the next couple of weeks. I know there's been some questions already just at the end of this week regarding some of the technical functions, some of the Linux syntax. For some of you, I realize this might be your first exposure to Linux, and the command line might be a little bit intimidating / confusing. And I just want to make sure that I'm going over some of the fundamentals for you to set you up to understand exactly what it is that you're inputting in the syntax. You know, it's one thing to just type a bunch of characters and text in Linux and then get an output, but I hope over the next few minutes and giving you some of the foundations of Linux and going through some of the step-by-step processes of some of the features, forensically speaking, especially from an imaging standpoint, that you'll understand exactly what the output is and also understand what it is that you're actually inputting. So I hope you'll find this to be helpful. You'll notice a couple of days ago in the announcements I did post a Linux guide for law enforcement. That is really a great start, and so I would really encourage you to go over that guide for a good introduction into some of the syntax and also understanding exactly some of the functions that you can do forensically with Linux, and hopefully you found that helpful. So let's just kind of kick off here and talk about the foundation. Maybe for some of you this is brand new, maybe this is ancient for others that have been in the Linux world, or if you're doing network forensics, I know some of you have mentioned that, or doing just traditional forensics, Linux might be familiar, but want to make sure that we're all at least somewhat on the same page. So as we talk about Linux, the directory structure, everything in Linux is either file or process, okay? And processes are really just special files, okay? So the top level of the Linux file structure is known as the root directory, okay? And the root home directory is designated by, as you can see here, by this little squiggly vertical line here, okay? And we'll talk about a little bit about the privileges that are associated with root and how do you actually get there, and some of the functions that you'll have to perform in your labs. You'll have to be at super user status or at root. So basic structure at root, that's the main directory. Generally no files there, but there are links to other directories. Then you start getting into bin, sbin, user bin, and these are binary executable files. Okay, so bin stands for binary, and you've got general executables in the /bin. In the sbin, you've got administrative executables, and then in the user bin, as you probably would imagine, that's going to be user accessible executables. Then you get into dev, which you would see in your labs starting out, and this basically stands for devices. The Linux environment treats devices as files, and the /dev contains a listing of all Unix, Linux special device files. Okay. Speaking of listing, if you are in a specific directory and you want to know the contents of that, all you actually have to do is do an ls, standing for listing, and some of that syntax, some of those shortcuts were in the Linux guide that I did provide to you. Then you get into etc, that's the Linux configuration, including the startup config files, and then the lib is the location for shared binary libraries. Some of the basics continued on the Unix basics. You get into temporary stores for temporary files. /var contains data which changes frequently, hence the word or the acronym VAR, varies, meaning it's a variable, and that would be your log files, your mail files, and then user, and that's going to be any user specific information, including your home directories and any user files. And then finally, as we start talking about forensics, we use this feature a lot. We start using mount, and that's a directory for mounting user-defined devices, and we'll actually talk about that more here in a few minutes, especially as we start talking about DD, and then also the DCFL DD that you'll look at later in one of your other labs in the course. Media, directory for mounting media devices like floppy drives, CD-ROMs, and then you get down to your home. That's your user home page. It's a good place to look for files that you create, typically as an automatic designation location for files that you've created. And then your boot, that's your directory partition exclusively for boot code. Now we get into our device types, and this is really important. One of the things I want you to understand as we talk about, especially in the labs, you'll see this terminology here, /dev SDA or SDB. So SATA drives, and we are obviously working in a virtual environment here, but still the way that the Linux environment sets up when you use something like Kali, it's basically using what's called a hypervisor. It's running a computer, an operating system within the confines of another operating system. For many of you Windows, you're using VMware Workstation or VirtualBox, and then you're basically still allocating resources from your physical drives. And so the way that the way that Linux looks at that, it says, okay, you've got a SATA drive, more than likely. Maybe you have USB. I'm going to venture and say that probably don't have any old school IDE drives, but at any rate, this is the naming conventions, and for most of you, it will be the second section here for SATA. And the way that it listed is for physical drives, you have SDA, SDB. That's for the drive portion. Now, under those drives, as you would see in Windows as well, you have partitions. Okay, so SDA1, okay, is the physical drive. SDA, the one partition or the first partition, all the way up to, you can go up to SDA4. Okay, and then you have, outside of the primary partitions, you then have 5 and higher. Those are your logical drives. Okay, so just to repeat, SDA, when you look at the alpha character, SDA or SDB, that's your actual physical drive that it's referencing. Okay, then SDA 1 through 4 is the partition of that drive, and then you get into your logical drives, SDA 5 and higher for logical drives. And then if you have a removable device, which will not be much of interest for you for this particular course in the environment that we have set up, but for future reference, you have dev FD0 to FD9, and then CD-ROM if you're working with an optical drive. And those are just some of the device types. When you look at partitions, hard drives, as we said earlier, are divided into partitions: primary, extended, and logical. The partition table, along with the master boot record, is kept on the first sector of the disk. Okay, that partition table contains information about locations and sizes of your partitions, and then the master boot record is used to actually boot the system. Now, when you partition a hard disk, very, very important here, when you partition a hard disk, this allows the disk to be treated as several independent areas instead of just one massive block of data. Okay, so instead of just having, as we go back to this section here, just this one block of data of a physical drive, you start partitioning it, it's basically giving you several independent areas to work with instead of just that one massive block. More information about the file structures. Okay, you'll see this as well. ext4, common for journaling, ext3, ext2, and then UFS for Unix file system. Okay. Terminals, as we talked about at the beginning, you have the $, which is your user, your standard level non-admin user, and then you get to root. Okay, some commands that you're going to use forensically are going to require you to escalate the privileges up to root, and the way you do that, in doing that escalation to get to this this number sign, which you'll always know you're at root if you're at the number sign when you're in the command line, is you're doing a sudo, so S-U-D-O, okay, or sudo, and that's actually what you're going to use in order to get to the root and to get those privileges. And sometimes, depending on what environment you're working in, there will be some type of password that might be required depending on what system you're using. But sudo and then space and then su, okay, to escalate up to a super user. And then after that, you actually will either have a password requirement once you hit enter, or maybe the system is open and you don't have to do that. So sudo space su and then space usually a dash after that would typically get you into the root level. So let's take a look at that. Okay, so we get into our Kali environment, and first thing we'll do is go to our terminal. And this is just to exemplify the command line, what you're doing to get to the super user. And there we go. So obviously here I'm already in the root. You see that by the $sign that's here. But let's just say that I wasn't, I'm sorry, the pound sign. Let's say I had a $sign there exemplifying that I was at user level and I need to escalate. So sudo space su space dash, and then obviously I'm back at root. So that's simply how you get there if you got a $sign, and again, depending on what environment that you're in, you may have to enter a password. So let's talk about disk imaging and some of the tools that we're going to use throughout the course as we're in this command line environment. So disk images are used, as we many of us know, to transfer a hard drive's contents for various reasons. Okay, a disk image can be used in to restore a hard drive's contents, maybe during a disaster recovery. You can use it to transfer contents of a hard drive from one computer to another, or to restore the contents of a hard drive after maybe a hardware upgrade or repair. Now, we obviously use it forensically as well. When we create a disk image file of a target, that is the first step of any digital forensic investigation. Okay, in any investigation, analysis is not done on the original data storage device, the target device. It's actually done on the exact copy taken. And so the disk image consists of the actual contents of the data storage device, as well as the information that's necessary to replicate the structure and content layout of that device. And that differs from a normal backup in that the integrity of the exact storage structure remains intact, and that's pivotal for us in maintaining the integrity of a forensic investigation. Okay, so we have several tools. One of the most basic that's native and what we're using with Kali that's mentioned in our labs is this DD, and that's a disk dump, and that's a Unix command that is used for a multitude of digital forensic tasks. It's a simple means of just obtaining a raw image of a file, a folder, a volume, or a physical drive. Now that's going to be the equivalent essentially of creating a disk image file in FTK Imager or in Encase for those of you that have experience with that. Obviously this is just more, this is command line. It's complete to be the terminal with the commands in Linux. It's not as, you know, graphically appealing, and it may be a little bit intimidating. Don't let it intimidate you, because essentially what you're seeing here in the Linux command line is what's going on essentially in the background with tools like FTK Imager or Encase. One of the tools that we'll talk about that I'll do a demonstration of here just to give you an explanation of some of the input that I think will help you with your other labs, and also you'll use this with your labs coming down the course, is DCFL DD. Okay, and that's an enhanced version of DD. Okay, and that's useful features with that, because you're getting more than just doing a disk dump. You're actually getting on-the-fly hashing. You're able to do MD5 or able to do SHA-1, and that's all a part of the same command that's associated with DCFL DD. You can get status outputs. You can do multiple outputs, log outputs. So a lot of great features that you can use with DCFL DD. So before we get to that point of using DCFL DD, we obviously want to get some background on understanding what the target drive consists of, or the different partitions and sizes and things of that nature. And so we'll talk about this a little bit later in the course with one of the utilities that we'll use, and that's actually called Fdisk. Okay, so with Fdisk, that particular terminal or that particular command will actually give us a printout of a list of the partitions that are on the particular machine. In this instance, the Kali machine. Now, mine might look a little bit different than yours does, and that's okay, as I'm working on a different version of Kali and I'm not on the vCenter. But make sure that I'm at root, and then I use Fdisk-L, and so this is again going to list out the partitions on the Kali machine. Okay, and so what I have here is 3 partitions. Okay, we talked about the partitions earlier. We have SDA, okay, being the actual physical device, and then the partitions here 1, 2, and 5, and we get some basic information about them. We get our size, the actual type itself, and then the sectors, and then the start and end points. Okay, so that's one utility that we can use just to give us some information about the particular target drive that we're working with. Okay, now if we want to see the amount of space on each partition, this is kind of an extra bonus. We won't necessarily use this in the course as much. It is a tool that you can use, though. We want to understand the space that's on those partitions. We then could use a command that's actually called parted-l. Okay, all right, so if I want to go back into Kali and then use parted-l, let me just zoom in here so you guys can see. Type it in here. There we go. So parted-l, still at root. Okay, and so that's just going to give me more information about the space that's on each partition, and we can obviously see what we're working with there. Okay, so with partition number 1, number 2, number 5, and we're looking at 40 gigs. 2 gigs roughly, and then obviously the file system type. There's that ext4 that we had seen earlier. Okay, so that's just a couple of the tools there. Let me go back now and let's look at this DCFL DD. Okay, so we talked about the DCFL DD as being a more enhanced version of just the regular disk dump, but still some of the same syntax that I want you to be familiar with either way. Okay. Regarding that particular feature set as it relates to doing the command line. Okay, so we get to the imaging portion. Okay, and let's say that we've maybe mounted a drive and we've written content to it. Okay, that's what you were doing somewhat in your week 2 lab. You created a particular file. You've got some content that you're working with. Okay, And so if we're looking at a tool like DCFLDD, first that we do is we actually launch the tool. That's the first line in the syntax, DCFLDD, and then we have what's called our input file. Okay, and the input file, we're just basically spelling out what it is that we want the system to do for us. And so my input file here, I'm actually going to use, and I'm not going to go through the whole process of the imaging here because it is a larger file. I'm going to use that SDA1, that's my primary, the ext4 just as an example. But that input file could be a text file, or maybe you've created some other evidence somewhere else if you're using a test environment to validate your tools. Or you're working with a target drive. Depending on what your scenario is, that input file is just that. Okay, so the command line begins with DCFLDD, and the input file here is just going to be that /dev, which we established earlier as our device. Okay, well, what device is it? And in this particular one, I'm going to do my SDA1, and that's just designating the drive that will be copied in the disk image. Okay, now obviously I want to do some verification, so we do what's called hashing, correct? So we do our hash, and then here we just decide what we want to go with, and I'm just going to use for this purpose just MD5. So that's what you're doing. So what I've done so far is I have designated the drive. Okay, I've said DCFLDD is a tool that I want to use. I've designated the drive that will be copied, and then I've said, hey, this is the hash that I would like to be generated as the disk image is created. Okay, and then there's a couple of other different options that you can go through. I'm not going to spend a lot of time on those. You can actually designate that the hash logs are going to be printed to certain locations, and maybe split those across two different file types. However you want to do that. That's basically going to be your log, and I will show you that. That's just an MD5 log, or if you're using SHA, it'd be SHA-1 log. MD5 log equals, let's say I wanted to put it at root, and I wanted to call it MD5.text. And this is the nice thing that we get with a tool like Fdisk Imager, right? We get an automatic log generated for us. So we're having to do a little bit more work here, but it helps you understand a little bit more about what's going on in the background as you type this stuff out. Okay, so this is again just designating the hash logs are going to be printed to a text file within the root folder, and that's the home folder. And at the end of that, there's other options we can go with, but just for simplicity, I can do this output. Okay, this is going to be the disk image of the disk image file that's actually going to be created. Okay, and so for here, my output file OF equals, I'm going to say root, and I'm just going to call it drive image.dd, which is our raw. You could do .eo1. Just depending on what you wanted your file type to be. You can always be safe though with using dd for your raw type. So doing the root ensures that it will be written to that home folder, just easier to access. Okay. Now if I hit enter on this, it's going to start doing the imaging, and it's 40 gigs. Obviously we would be here for quite a while. Okay. So that's just a little bit of a breakdown for you on some of the syntax. Now if I hit enter on that, it starts doing the imaging. I then go back to my home folder. I would see a text file there for this MD5 log, and then I also would see this drive image.dd. Okay. And that's just where those would be placed once you were to go back into your home folder. You would see those outputs there. Okay, so I hope you find this helpful. This is just a little bit of a breakdown of the Linux structure and some of the tools that we'll use coming up. And I hope you'll find this helpful for those of you that are new to Linux. Let me know if you have any questions, and I hope you guys enjoy the rest of your week in conquering the labs. And look forward to engaging with you folks soon. Okay, take care.